Hello everyone, welcome back to Math Verse by Vishal. So, is this the most difficult question which was asked in the JEE Advanced from the chapter Definite Integration? Because is it involving more multi concepts and also multi chapters? Let's try to find out and tackle these kind of questions, right? So, let us start the question. First of all, I'm going to rewrite the function. Observe carefully. F of x is equals to, this is limit n tends to infinity. Now, instead of writing all the terms, I'm just going to write that entire numerator as a pi notation, product of terms. Okay. So it is n to the power of n multiplied by pi r is equals to 1 to n x plus n divided by r. Okay. In the similar way, what about the denominator here? It is n factorial multiplied by. Now, what is the general term in the denominator? It is clearly x square plus n square divided by r square, right? So, I'm going to write it as pi notation. R is equals to 1 to n x square plus n square divided by r square. And then we have whole to the power of x by n also. Okay. Now, let us try to simplify that part here. What we are going to do is limit n tends to infinity. This is n to the power of n multiplied by. In the numerator, I am going to take that n by r common, which gives us pi r is equals to 1 to n by r multiplied by 1 plus x into r by n. Similarly, in the denominator also, I am going to write it in this way. Observe n factorial into pi r is equals to 1 to n, and in the denominator obviously I am going to take r square n square by r square common. So n square by r square multiplied by 1 plus x square into r square divided by x square whole to the power of x divided by n. Okay, this is the first thing that I'm going to do here. Okay, and what was the reason that I'm taking n by r and n square by r square common? The only reason is we have the standard form, right? That is limit n tends to infinity 1 by n into sigma of f of r by n. So whenever we have limit of this form, we can simply replace r by n with x and then convert this limit into an integration based question, right? So that is the idea here. Okay. And then I'm going to split the pi notation here, that is limit n tends to infinity. This will be n power n multiplied by. I can write this as pi r is equals to 1 to n by r multiplied by, this is pi r is equals to 1 to n, 1 plus x into r by n, and whole divided by, this is n factorial multiplied by. Again, I'm going to split the pi notation in the denominator also. R is equals to 1 to n. This will be n square divided by r square and multiplied by, this is pi r is equals to 1 to n, 1 plus x square into r square divided by n square, and again we have whole to the power of x by n. Okay, now what's the reason behind separating the terms here? Because I can calculate these terms directly. If you observe carefully, when you expand this pi notation, what is the term you're going to get? It's just like n into n into so on up to n, and in the denominator we have, since r is equals to 1 to n, it becomes 1 2 3 so on up to n if you expand the first term in the numerator there. And what is this? Clearly n into so on, nothing but n to the power of n divided by, what about the denominator part? It is clearly n factorial. Okay, and in the similar way, I'm going to simplify the denominator part also. Look at this. When you expand this pi notation, what you are going to get? N square into so on up to n square, since r is a variable here. And what about the denominator? 1 square into 2 square into so on up to n square. So what about the numerator in this case? It is n square multiplied n times, so it should be n to the power of 2n divided by, if you look at the denominator, can I say it is directly n factorial whole square? So that's the advantage here. Okay. So these are the numerator and denominator first pi notations. Now let's take it and put it back there and see what we get. Limit n tends to infinity, n power n multiplied by n power n divided by n factorial multiplied by pi r is equals to 1 to n, 1 plus x into r by n whole divided by, this is n factorial multiplied by, what about the denominator? N power 2n divided by n factorial whole square. and multiplied by pi r is equals to 1 to n 1 plus x square into r square divided by n square, and once again we have whole to the power of x divided by n. Now the main advantage in simplifying in this way is, if you observe carefully, this n power n into n power n is 2 n to the power of 2n, that get cancelled with n power 2n. Look at the remaining terms also. N factorial, n factorial, n factorial whole square, everything will be cancelled out. So we have somehow simplified it. Okay. Now let us write down the remaining function f of x. Okay. So we have f of x is equals to, finally, limit n tends to infinity by r is equals to 1 to n 1 plus x into r by n divided by pi r is equals to 1 to n 1 plus x square into r square divided by n square whole to the power of x divided by n. Now it is somewhat looking similar to our standard notation, that is 1 by n into sigma f of r by n. So this is the ultimate idea. So this is the first part here, and now starting the concept of what? Converting this limit into definite integration. So let us do that. Since we have product of the terms, obviously I have to apply log on both sides. So I am going to get ln of f of x is equals to, if I apply log on the right side, it becomes log of some a to the power of m, which becomes m into log a, right? So I'm going to write that, observe carefully. Limit n tends to infinity, this becomes x by n multiplied by, and this will be ln of pi r is equals to 1 to n 1 plus xr by n whole divided by pi r is equals to 1 to n 1 plus x square r square divided by n square. Okay. So this is after applying logarithm on both sides. But what is the advantage with this one? Here this is log of a by b form, which can be written as log a minus log b. So I'm going to do that. This becomes, moreover, here in this limit x is a constant, right? And I'm going to take it outside. The remaining part will be limit n tends to infinity 1 by n into, and what is the numerator part now? It is clearly ln of pi r is equals to 1 to n 1 plus xr by n minus of, again this will be ln of pi r is equals to 1 to n 1 plus x square r square divided by n square. Okay. Now if you observe carefully, this is like log of ABC, because when you have product notation, what is the meaning of that one? So it's like some A into B into C. So when you have log of A into B into C, it is nothing but log A plus log B plus log C. So log of pi notation changes to sigma notation, right? I hope you got the point there. If I write log of pi of A, it's like log of A into B into C, which is going to be log A plus log B plus log C. So I can write it as sigma of log A. So this logarithm changes pi notation to sigma notation. So that is what I am going to do here. X into, finally, limit n tends to infinity 1 by n whole multiplied by, let's change this into sigma notation. Sigma r is equals to 1 to n. This will be log of 1 plus xr by n, and minus of, similarly this is also sigma r is equals to 1 to n log of 1 plus x square r square divided by n square. Okay. Now finally, if you look at both the terms here, it is just looking like the form 1 by n into sigma of log sigma of some f of r by n function, right? So what do we do for that? So whenever we have this standard form here, 1 by n into sigma r is equals to 1 to n f of r by n, we simply write it as integral 0 to 1 some f of t dt, right? So this is your idea, replacing r by n with t and integration 0 to 1. So that is exactly what I am going to do here, which is x times of, finally, the first term integral 0 to 1, this will be ln of, now ln of 1 plus r by n is replaced with t. So ln of 1 plus xt and then dt. Similarly, minus of the second term integral 0 to 1, which is exactly ln of 1 plus x square into r square by n square is nothing but r by n whole square, which is t square of dt. Now clearly I can write down finally ln of f of x here. So ln of f of x will be is equals to x times of I can write this as directly integral 0 to 1 ln of 1 plus xt divided by 1 plus x square t square of dt. Okay, so let's keep it as equation number 1. So somehow we have got the ln of f of x function here. So as you can see, this is how you are converting the given limits question into a definite integration question. So this is a part 1 of this question, right? Now let's look at the options and try to get the idea what to do next here. Look at the option A and B. They are comparing the functional values, and option C and D, they are asking us to find out the value of f dash of 2 and f dash of 3 by f of 3, right? So obviously we have to differentiate this equation 1. So look at the equation 1. Can we differentiate directly? Obviously we can, but before that I'm going to do a small point trick here. That is, in the right hand side, I'm going to put x into t is equals to z. X into t is equals to z. So that if I differentiate with respect to t, this becomes x into dt is equals to dz. So I'm going to put that back here, and the question changes to ln of f of x is equals to this x multiplied by dt becomes dz. So integration of dz, and the question changes to this is ln of 1 plus z divided by 1 plus z square. But we have to change the limits also. Don't forget that. So when t is equal to 0, z is equals to 0. But when t is equals to 1, t is equal to 1, then z is equal to x here. So this question changes to integral 0 to x. Okay. Now you would have understood why I did this one before differentiating, because on the right hand side we cannot use the Leibniz rule directly because one more variable x is involved there. This is what I have told you in one of the previous videos also, where it is a complete trap if you do the differentiation directly by using Leibniz rule. Okay, now let's start differentiating it. Okay, so if I differentiate this one, I'm going to get something like this: 1 by f of x multiplied by f dash of x is equals to, and what about the right hand side? By using Leibniz tool, I'm going to get this as ln of 1 plus x divided by 1 plus x square multiplied by 1, because the upper limit is x, differentiation of x is 1. So from here finally we have got f dash of x is equals to f of x multiplied by ln of 1 plus x divided by 1 plus x square. Okay, now first thing, I'm going to find out the critical points of this function, because when you want to compare the functional values in this way in option A and B, we should know whether it is going to be increasing or decreasing interval, decreasing function, and in what interval it is increasing or decreasing. Okay, so for that, first thing I'm going to find out the critical point. I will make f dash of x to 0. If I make f dash of x is equal to 0, it becomes f of x multiplied by ln of 1 plus x divided by 1 plus x square is equal to 0. But clearly, if you look at the question, given that x is positive and this entire limit n tends to infinity function is there, right? It obviously is a positive value. So which makes f of x as always positive. You can cancel it out. And finally, ln of this sum t is equal to 0, which makes 1 plus x by 1 plus x square is equals to 1, right? And if you cross multiply, you get two values of critical point, that is x is equal to 0 comma 1. But since x greater than 0 is the domain, obviously the only critical point we have is x is equals to 1. So at this point you're going to get either a maximum or minimum or neither, and that one you have to check by using the first derivative test. Okay, so we have to do the smart work here. F dash of x is equal to, this is f of x multiplied by ln of 1 plus x divided by 1 plus x square. Now let's start thinking here. Let's say this is a number line sign convention for f dash of x function, and x is equals to 1 is our critical point. Okay. Now think smart here. If you put a value x greater than 1 in this function here, and anyhow we don't have to worry about this f of x value because this is always positive. Okay, now think properly. In this function, if I put 1 plus, that is f dash of 1 plus, what will it be? Ln of 1 plus 1 plus divided by 1 plus 1 plus whole square. So if you calculate that properly, you are going to get logarithm of some fraction value. So it is going to be ln of a value which is slightly less than 1, okay, because it is greater than 1 case, right? And ln of a value which is greater than less than 1 is going to be negative, so which makes in this case f dash of 1 plus as a negative value. I hope you get the point here. Like what I'm saying is, if you put x is equal to 1.1, what do you get? You get 2.1 divided by 2.21, which is a value slightly less than 1, right? So clearly ln of a value slightly less than 1 is negative. So that makes f dash of 1 plus as a negative value here. Okay. And in the similar way, if you try to put f dash of 1 minus here, try to imagine, let's say you are putting x is equal to 0.9. What do you get? 1.9 divided by 1.81, which is greater than 1, right? And that is the reason you are going to get this log function as a positive value there. I hope it is clear. You get something like this, ln of 1.9 divided by 1.81 if you try to put a value slightly lesser than 1, like 0.9. So clearly this is a value greater than 1. ln of log of or ln of a value greater than 1 is positive. That is why f dash of 1 minus is positive. So what's the observation here? Before 1, f dash of x sign is positive. After 1, f dash of x sign is negative. So clearly at x is equals to 1, the first derivative is changing sign from positive to negative, which makes x is equals to 1 as point of maximum. Point of maximum. Okay, so we need all these things here. So we understood that this f of x is going to have a point of maxima at x is equal to 1, which means the graph might look something like this at x is equal to 1, right? Since it is a point of maxima. Now what you can understand here, when x is less than 1, the function is increasing, and when x is greater than 1, function is decreasing here. Now look at the option A and option B. In option A, they are comparing 1 by 2 and 1, right? So very clearly you can see that 1 by 2 is less than 1, but since in this interval it is increasing, I can say that f of 1 by 2 will be lesser than f of 1. But what is the option 1 here? It's exactly reverse given that f of 1 by 2 is greater, so which means it is wrong. What about 1 by 3 and 2 by 3? If you compare 1 by 3 and 2 by 3, so 1 by 3 will be lesser than 1 by 2, and clearly f of 1 by 3 will be lesser than f of 1 by 2 here. Okay, and which is exactly the option B here. F of 1 by 3 is less than or equals to f of 2 by 3, so which is clearly correct. And since it is an increasing function, which we are not changing the inequality sign. Okay, now? So I hope it is clear, and that's the reason we should know whether it is increasing or decreasing before 1 and also after 1 here. So we have verified for option A and also option B. What about option C here? F dash of 2 value. Very clearly, you can notice that just by looking at the sign convention, we understood that after x is equal to 1, f dash of x is going to be negative, right? So clearly I can say that f dash of 2 is going to be negative just by looking at the sign scheme we have written for f dash of x. So that is the reason I have written the sign scheme for f dash of x here. And one last option to verify is this, that is f dash of 3 divided by 3 greater than or equals to f dash of 2 divided by f of 2. So for that we can simply take this expression that we have got, this one, f dash of x divided by f of x from here. Okay? I hope you notice this. F dash of x is equal to f of x into this value is there, right? Just to take that and then bring that f of x to the left side, and you can write it as f dash of x divided by f of x is equals to ln of 1 plus x divided by 1 plus x square. Now since they are asking about 3 and 2, put x is equal to 3 and x is equals to 2 and subtract both of them. So that is the procedure. Put x is equal to 3, this becomes f dash of 3 divided by f of 3 is equals to, this will be ln of 10 divided by, and sorry, f of ln of 4 divided by 10. And if you put x is equals to 2 here, this is f dash of 2 divided by f of 2, which is equals to ln of 3 divided by 5. And you subtract both of them, that is f dash of 3 divided by f of 3 minus of f dash of 2 divided by f of 2 will be is equal to, when you subtract these two, it is like log a minus log b, so log of a by b, what you get is 4 by 10 whole divided by 3 by 5. This is 5 2 times and 2 2 is 4, and finally what we get is ln of 2 by 3. But just now I have told you, right, log of a value less than 1 is obviously a negative value. So which means log of ln of 2 by 3 is negative. So finally you can say that this entire value is less than 0. Now you can take this term to the right side, and finally you get the conclusion f dash of 3 divided by f of 3 is clearly less than f dash of 2 divided by f of 2. But I think it is exactly reverse in the option D here, so which makes option D also false. Okay. So as you can see, this is what you have to do to get the correct answer in this question here. It's a multi-concept and also a multi-chapter question. So many concepts are there here. Okay. So I hope you have understood how to tackle these kind of difficult questions from integration part. Okay.